We look at your virtual day number 2 assignment. First question, they're asking you to find the area of a circle. So we look at our reference sheet. Area of a circle, it's pi r squared. They want us to use 3.14 for pi. We can see from the picture the radius is 14. They would not have had to put r equals there, by the way. Okay, don't expect them to do that for us all the time. So we're doing basically 3.14 times 14 squared. They want us to round it to the nearest hundredth. So it should be 615 and 44 hundredths square meters, because we're doing area. Question 2, they want us to find the slope of the line. Slope, like they mentioned, is rise over run, or I like to say change in y over change in x. As we discovered on a worksheet the other day, it's probably best just to go with the points that they have given us, just to be safe. So change in y, we're looking at going up or down. Probably before I even start figuring this out, I would just at quick glance notice this is what kind of slope? Negative slope. Good. Okay, remember negative slope, because then we can kind of create an n for negative out of that. Okay, so if we look at this, change in y, we're going down how many units? 4. Okay, so we'll call that a negative 4. And then we're going over 6. Okay, so our slope, to start out, we could say our slope would be negative 4/6. Anytime if we have a fraction, we're going to try to reduce that if possible. These are both even, that we could reduce by 2, and that would be negative 2/3 would be our slope. I believe how this question was set up, if you did not reduce that, it still would have accepted that as the correct answer. But again, always just try to reduce your fractions if you can. On your calculators, remember, you can divide that out. And then second, PRB, that's the little F to D deal. That'll actually reduce the fraction for you if you have access to that, or if you're able to just use that to check your answer. I like to start with the point on the left, but another option here would be to start with the point on the right. In that case, we would be going up 4 and to the left 6. So that would be 4 over negative 6, and that would work out the same. Normally they'll put the negative sign with the numerator, but understand the slope essentially is the same. Positive divided by negative, or negative divided by positive. Either way is going to be a negative number. Number 3, basketball team raises $3 for themselves every game they play. Graph a line to represent this relationship. One thing they didn't do here was label the X and Y axes. So this should be, probably we want to see a change in how much money they've raised. So usually what we want to see a change in, we would put that on the y-axis. So this would be like money raised in dollars, and this x-axis would be the number of games. Okay, so we could just do a couple of things here very simply. We could say 1 game they would raise $3, 2 games they would raise $6. Okay, now any old 2 points would give you a line. The thing that's going to make it for sure is if we get a third point to line up with that. So 3 games would be $9. And then we can see that those look like they're going to line up with each other. So we can just draw a line kind of going through those points there. Maybe off by a little bit, but put an arrow on the end, and we should be good. Number 4, once again, we're trying to find the slope. This one looks like what kind of slope? Positive slope. Okay. I'm going to use their points again just to be safe. So if we do this, we would be going up 8 and over 7. Okay, so our slope would be 8/7. Good. Now 8/7, you guys can just leave that as a fraction. If you're typing it on the computer, it might just look sideways, 8/7. Or actually, I think there's a little thing where you can do that maybe, and then put in 8/7. Number 5, they wanted you to graph a line with a slope of -5/2 going through the point -4, 1. This was actually incorrect with the answer they were trying to do for you. So my apologies. I tried to look a little bit better this time and make sure that they're doing their problems right. -4, 1, remember x and then y. So this would be -4, 1. And then we want a slope of -5/2. So -5/2, remember, slope is a change in y over a change in x. So if the slope is -5/2, means we're going to go, change in y is -5, would go down 5 and over 2. And so that should be what our line's going to look like here. Something like that. I'm not sure what the point A is doing on the graph there, so you can just kind of ignore that, I guess. Unless you're supposed to drag that over. Okay, yeah, so just ignore the point A then. Question 6, we have an unusual shaped yard here. They want the approximate area of Laura's yard. So you can see they've kind of already got it split up for you as kind of a half circle and a square. This half circle is what we have to be careful about. We know the area of a circle is pi r squared. If we're doing half of a circle, we could take half of that area. Or you could take the area and divide it by 2, however you want to do that. So approximate area, I think we were using 3.14 for pi here. It doesn't say, but okay. We use 3.14 for pi. And what we have to watch here, our radius is what we're wanting. 17 actually would be going all the way across. That would be like our diameter, if you can imagine this. Okay. So we would take half of 17, which would be 8.5 or 8.5 would be our radius. So that would kind of maybe be a first step for us. And then we can work that out. 226.865. And then the bottom part is just a rectangle. Is length times width, technically a square, I guess. 17 times 17 is that 289. Okay, and then what will we do with those? Add those together. This first part, actually, we forgot to take half on our circle, so this would be a 113.4325. So 113.4325. And then we add those together. Is 402.4325, so that would be closest to answer choice B. Okay, so again, a couple easy things to make mistakes here we got to watch is making sure we're using our radius, not our diameter, making sure we're squaring the radius, and making sure we remember to take half of that area of the circle. Question 7 is making a donut here. So Notice on this they want us to leave our answer in terms of pi. So we're going to do pi r squared for a circle. The big circle, if this didn't have the hole in the middle of it, this would be pi times 6 squared, which would be 36 pi. And then the middle part, radius is 2, would be pi times 2 squared, which would be 4 pi. And then we would just need to subtract those, which would be 32 pi. You actually have to work it out this way. You can't just say, well, 6 minus 2 is 4, so 4 squared, 16 pi. Notice that's not the same answer we got. So no shortcuts here. We got to find each one separate and then subtract. And I will go back, if I haven't already done so, and check your answer to see if you got the correct numbers and everything. There wasn't a pi button there. I said for you guys just to write the word pi, but apparently that didn't work either. So if you have something resembling 32 pi for your answer, I will go back and mark that as being correct. Number 8, an office pays a company to collect recyclable paper each week. The recycling company charges a $20 collection fee. And 30 cents for each kilogram of paper it collects. I'm not doing a real good job here drawing my lines. Be careful when you draw your lines. Make sure you don't lose your decimal points by drawing those. Last week the office had to pay the recycling company $59.60. So first thing they want us to write an equation. Before we write an equation, we're going to define our variable. So the variable, the thing that's changing would be the amount of paper that it's collecting. So we could say let X represent the number of kilograms of paper the recycling company collected. The more specific we can be about defining our variable, the better off that's going to be. So that would be defining our variable. And then the equation, think about what the costs are. Costs would be $20 plus 30 cents per kilogram. So $20 plus 30 cents times X equals $59.60. If you wanted to use a different variable, if you wanted to do K for kilograms, P for paper, whatever, that's fine. I just use X a lot of times. So that would be an equation. And then part B, this week the office projects they will have 20% more recyclable paper than last week. Based off the projection, how many kilograms of recyclable paper will the office have this week? So the first thing is that we don't actually know how much they collected last week. So first thing would be that we would have to figure that out. And I'm not going to have a whole lot of space how I'm writing this, but so we want to get our variable term by itself. They're adding, so we can subtract 20 both sides of our equation. And then they're multiplying, so we can divide. When we divide here, we're dividing by a number less than 1, so our answer is actually going to get bigger. And we divide that out, would be 132. So what that means is 132 pounds last week is what was collected. Or sorry, not pounds, kilograms, right? So 132 kilograms last week. This week it's going to be 20% more than that. So one way of doing this, we could take 20%, find 20% of 132. So 20%, change that to decimal, times 132, or 20 over 100 times 132 would be 26.4. And then so we subtract then 132 minus 26.4 would be 105.6. So 105.6 kilograms would be our final answer for this part. Another way you could do this second part of the problem would be 100% would be the full amount. So 20% more than that would be 120%. So we could say, let's find 120% of 132. Sorry, I just noticed a mistake here. This is more and not less, so I should be adding. So actually should be 158.4 kilograms. Okay, always make sure you check your work, think about if it makes sense. Make sure you're reading the directions carefully.